It is about a year since I published my last SHO tutorial for PixInsight. A year, at least in my age, flies by like nothing. The fact is, this tutorial changed so massively as I could never imagined a year ago. And yes, the title is true. Based on all the new scripts and processes, the results you can reach today compared to a year ago are way better. And all these scripts enable you to do it much faster and much easier. And so join me today in processing the Eagle Nebula in the fastest, easiest and best way possible, right after the trailer. Hey, this is View into Space. I'm Sascha from Switzerland, so grüezi miteinander and thanks for watching my channel. So I think I mentioned already most in the intro. All the improvements that we have seen in the last year, from BXT2 to gradient correction, to all the Toolbox scripts and so on, it's really amazing. And it makes a lot of stuff redundant that you still had to do in a very cumbersome way a year ago. Now there is something else fundamentally different from what I did a year ago or with most of my tutorials until now. Most of the time I used on purpose very bad data to actually show you the improvement potential that you have with processing. This time around we will go exactly the opposite way. I will use for this example almost the best data that money can buy. And that is from a commercial site called Dark Matter's Astro. And soon in another video I will tell you much more about this site and the unique data they provide. But for today, for this tutorial, I always feel you can do that very well with your own data and you can follow along. But if you like the Eagle Nebula and you want to follow along with me with this data set, there is a coupon here and you can get it on the Dark Matter's Astro site for 50% discount. And as always with these tutorials, there are a lot of steps involved. If you want to have everything nicely displayed on PDFs for further usage, please visit my Patreon site where you can find that and much more. And with that, let's get going. Okay, welcome to my computer and welcome to PixInsight. What we have here at the screen are the three emission channels, HA, O3 and S2. Now in case they were not stacked together, that you would have to do star alignment, so the registration. But if you stack them together, either here in WBPP or in app, for example, they are already registered. And also, by the way, if you're using mono, then this is completely familiar to you, having three dedicated channels. If you're using a one-shot color camera, you can also achieve to actually get through the three channels by using specialized dual narrowband filter like ASCAR, for example, offers with the D1, D2 or C1, C2 filters, where you have on one narrowband filter the O3 and the HA, and on the other narrowband filter the O3 and the S2. Important is that now, when we start, that you have all the three channels present. So let's use now the auto screen transfer function, and let's make sure that we see something. Now the first thing we would do when we have actually shot this ourselves is to crop it, because all the stacking artifacts have to be removed. And that is still the same as a year ago. Here it's absolutely unnecessary, because when you buy data it's already cropped nicely. But just for the sake of it, I want to show it to you. Dynamic crop. We're clicking on a picture. Usually we take the one where we have the biggest stacking artifacts. You click here on reset, the picture gets a little bit blurry. Now we're actually cropping it to the size that we want. Here I will now crop just a tiny little bit because it's anyway not needed, like this. And now what you do, you take the triangle, but you don't put it on here. You just put it on the background and let it go. So then you have this process one. You can close down the dynamic crop. And now all you have to do, you take this process one, throw it on here. Next one, throw it on here. And the last one, throw it on here. And we do it like that, you're sure that all three pictures have exactly been cropped the same way, so that you don't lose the registration, that everything is fine. And that's what the cropping is. Afterwards, you can actually delete this process again, that we have a clean surface to work. The next thing we're going to do is the gradient correction, and that's one of the big changes now. We're not using DBE, AB, Grexpert, whatever anymore. We use gradient correction. Now at the moment we have it on default. Now let me just run you here through the most important points. First of all, gradient correction is no one button tool. So just taking out the triangle and throw it over does not suffice. On the other side, when thinking a little bit logical, it's very easy to actually set it in a way that it works really, really nice. But also to mention it here, we're at the very, very start with this tool, and I think the more experience we get with it, the better it will be. And also PixInsight is still working to change this a little bit, what we see. They will introduce rather soon some auto functions here, which will make it even easier. So what do we see here? What we see is that we definitely have a little bit of gradient. It's a little bit brighter here than it is here. On the other side, this is really, really smooth. So what does that mean when we apply it now to the gradient correction? First of all, structure protection, why not? We have some bright spots, might help, we just leave it on by default. Then this automatic convergence, from what I understood, it can never hurt. Let's select that. Now smoothness, as we said, this is a very smooth gradient going from dark to bright. So we will actually up the smoothness to about 70, I would say, and the scale always has to be adjusted in the same way. That's what they tell us from PixInsight. And from my point of view, that's good enough. There's nothing more spectacular here. And with that, we throw it on here. It's already done. And when I look now, this area and this area have about the same brightness. So from my point of view, that looks good. We do the same here with the HA. Looks also nice. And with the S2. There is, by the way, a lot of question, should you do it separately by channel, or should you first combine the channels and then actually do the gradient correction? I think it depends on two things. On one side, on how you shoot. If you shoot in a rotational manner, means 5 red, 5 blue, 5 green, 5 red, 5 blue, 5 green, and so on, I would say you can combine it, because it will anyway be a mix and it should be about even Steven from a gradient point of view. But if you first shoot all the reds, then all the greens, then all the blues, or here with the emissions, then moonlight might change, there might be a meridian flip and so on, so gradients might look very differently per channel, and then it makes sense to do it separately. And I think the other point is that with RGB, the light is actually more evenly, or the light pollution is more evenly distributed between the channels. With narrowband, you have, for example, much more light pollution in the O3 than in an S2. So also from that point of view, with narrowband, it makes probably sense to actually do the gradient correction per channel. And as you have seen, as it is so easy now with gradient correction, there's also not much more time. With that, we can close it down. And with that, we actually come already to the point where we will combine the pictures to a color picture, and actually to 2 color pictures. So let me explain. In this case here, we do not have RGB stars. This is just how it is sold. Simply the narrowband exposures. And it might also happen to you that you do, out of whatever reason, not have stars. In this case, I will show you now how you can actually create out of these 3 pictures decent synthetic stars which look great. If you have RGB stars, you do not need that. Please just combine the RGB stars as any RGB image with a channel combination, and then you can still run with it with this workflow from the point on where we actually created the synthetic stars. So what we need now is pixel math. Here we have pixel math, and in pixel math you take away here the use of single RGBK expression. So then these light up here, and now we start entering the formulas. For R, it's this formula. For G, it's this here. And for blue, it's rather easy, it's O3. Now, as always, if you would like to have all of this, the whole workflow, with a nice diagram, with explanations in a PDF, you will find that on my Patreon page. So next thing is we open here destination. We state that we want to create a new image. Color space is not the same as target, but RGB color. And that's all we have to change. We throw the triangle on one here of the pictures, and here we go. And that's how it looked like. Looks very strange, but trust me, it will turn out fine. For the moment, we label this as stars and minimize it for a second. Now to actually combine the other three pictures to our SHO picture, we can either continue, because we are already here in pixel math, we can continue here, or you can take here the channel combination process. Given the channel combination process is easier, it's quite intuitive. I want to show it here in pixel math. The O3 we can leave. Here obviously SHO, so we just leave here the S2, and in green we just leave the HA, and that's also all we have to do here. Throw it on here again, and we have it. If you're going to do it with a channel combination, it will look exactly 100% the same. It really doesn't matter, pixel mask or channel combination, they do exactly the same thing. We call this here starless. And now we can actually already close down the other three. We do not need them anymore. Now, it really doesn't matter which one you want to do first. I would say let's start with the stars. So with the stars, the next thing we have to do is SPCC, because that can't be the right colors, right? And for doing SPCC, you have to have the picture solved. In this case, it isn't solved. If you have stacked in WBPP, it will be already solved. So in my case, we go script, image analysis, and image solver. Now with the image solver, a lot of things were also going on through the last month in PixInsight, and that's just not visible. But the capability of the solver to actually solve it, even when not all these data is 100% exactly entered, has actually increased drastically. So still we're looking for the object, that's M16, Eagle Nebula. Okay. Here, for example, date and time, I have no clue. I will assume this was last year, probably somewhere in fall, and I'll leave it already at that. Now the pixel size is probably taken here from the fit. Pixel size of the camera is usually 3.7, but probably it was drizzled. The focal distance looks, just at looking at it, at around 800 millimeters, I would say. And with that, which is my approximation, I press OK. So, and it has done it nicely. So this is really great. It's now much easier to work with Image Solver. As next comes now the SPCC. Here we leave the average spiral galaxy. I know what image sensor it is, so I choose it. I also know what filters have been used. These are the chroma filters. And that is actually all I'm going to do here, and I just throw the triangle over. And look at that, how nicely this graph correlates. So it's really perfect. We can close this down. Now comes the surprise moment, auto screen function. And look at that, it looks already so much better than before. Sometimes there's the question about background neutralization. When you do SPCC, background neutralization is included, so you don't have to do it again. So the next thing that comes is obviously the Terminators. And we start with Blur Exterminator. We really don't have to care here about the structure, because this is only about the stars. And the question is simply, how much do we want to reduce them? When we look now at them, they're definitely too large. Default is 50. We can actually say we go even a little bit further. We go to about 60. We adjust the star halos We might actually even like them here, so we can even increase them a tiny little bit that it still looks nice. And we throw it on here. And here we go. That's so much better. Just to show you the difference again. This is before, this is after. Perfect. We don't need noise exterminator for the stars because the background is anyway gone afterwards, so that doesn't make any sense. So we can already now extract the stars. For that we need the star exterminator, generate star image, yes, that we need. On-screen stars you never use if you use SXT in the linear phase, which you should. So all you have to do is throw this over. And here we go. Here we have the stars. Here we have the background, which we do not need anymore. We can close this down. Can close the star exterminator. Perfect. And now comes the last thing we have to do here with the stars, and that is to stretch them. And also here we do something completely new. And I really want to give credit here where credit belongs, and that is Adam Block, who actually developed this method and also created a video probably around 4 or 5 months ago about it. The issue is that there is no better stretching than what you have right now. That's exactly how it should be. Now, if you would actually take away the auto screen transfer function and then have to stretch it new, you have a hard time even getting to this result again. And that's why all we want to do is to make this permanent. And for that, we actually need the screen transfer function and we need the histogram transformation. And so now what we're doing is quite simple. We just leave it here as exactly as it is. Take the triangle of the screen transfer function and put it here on the histogram transformation. You immediately see that the curve here changed, so it worked. That's very crucial, that you see that a change here happens. Then you take here the triangle from the histogram transformation and throw it again on the stars. Now obviously this will look hideous, but if you now disable the auto screen transfer function, it looks perfect. It looks exactly like before, and within a few seconds we have actually stretched this. No hassle, no issues. And ladies and gentlemen, these are our stars. Now at the very end, we can still see if we have to reduce them a little bit more. There's a great script of Bill Blanchin, or if you want to leave it like they are right now. But for the moment, we leave them. Everything's fine with the stars. And with that, we actually come to our main picture, because that's what we're really interested in. The stars, they're not the star here. This here is the star. So, and when you look at this picture now, this is the reason why some people have issues with SHO, because it just looks so greenish. So we have to get this to a decent shape, right? The reason why it looks so greenish is because HA is obviously very dominant here. And so we obviously have these 3 emissions to evenly distribute, and then it will look better. So how do we do that? We have in the Toolbox, which you hopefully until now have installed. If not, have a look at my Toolbox video and install this script package, because it's really amazing and we will use it a few times within this video. So here in the Toolbox you find Auto Linear Fit. So we just check here, starless. We leave it as at lowest mean. That's what you usually use for linear fit, and you click OK. Might look strange now, but when we actually click the auto transfer function again, look at that. That looks really, really cool now already. So what comes next are the Terminators again. We start again with BXT. Here it doesn't really matter that much how much we sharpen the stars, because we're going to rip them out afterwards anyway. Here much more important is the non-stellar adjustments. I kind of think the 70% is quite good. We throw it on here. Okay, and it's done. And I want to show you now something, because this is really mind-blowing. You know what they say, that some people say, well, actually the changes with BXT, they're not even that big. Now, what Ross always says is that when it comes to BXT, it really depends on the data. The better data you have, the more impressive is the performance of BXT, because there's data around it can uncover. Now, this here is about the best data money can buy. So if we now undo here, look at that. That is just crazy good. I go even closer here. Gosh, there's so much detail that actually gets unveiled. So, and that's really for me amazing with this data. When I worked with this data, the performance of BXT was just unreal. So now with data this good, you could ask if you should even use Noise Exterminator. We can actually zoom in, and there is a little bit of noise if you look here. So it's not like there's no noise at all. And so my opinion is Noise Exterminator can never hurt. Obviously, we do not have to leave it full-blown here at 90% with data like that. If you go with about 70%, that's good enough. But now some people will say, this looks actually hideous. Now you have these patches here. So actually, Noise Exterminator destroyed this picture. Now, this is just a mistake of PixInsight. If I now go here to Image, Screen Transfer Function, and activate here Use 24-bit STF LUTs, look at that. Looks perfectly smooth, no patches anymore. So never be afraid of that. NXT has, out of one reason, the requirement that you enable that, and when it's enabled, everything looks smooth and soft. So the next thing we have to do is we have to exterminate the stars, which are anyway horrific. So we go Process, Star Exterminator. We do not need a star image. We want to never ever see them anymore. And here it goes. And the picture looks actually even more beautiful now without the stars. I really like this. It looks like paintbrushes. Just beautiful. As the next thing, we have to stretch this picture. And that's not actually so easy, which is kind of funny. But the issue that I experienced, and I will show you, is that the darkest parts here, if you look below, they are at about 1024 at the moment. If you look at the brightest parts, we are at about 1100 and something. So it's very close together. That makes it very difficult to stretch this picture. Also with GHS. And I will actually show you what happens if you try to stretch that with GHS. So let's do a clone. There we go. As we should, we actually deactivate auto screen transfer function. Go generalized hyperbolic stretch. If you never use generalized hyperbolic stretch, I would recommend that you do a full tutorial about it, because it isn't an easy process. I cannot explain you this within this tutorial. The best tutorial from my point of view is the tutorial of Adam Block, which is free on YouTube. Takes you about an hour, but he really explains it in a very good way. If this is just too lengthy for you, I also have a GHS tutorial. So, but now let's try this. So we actually magnify as we should. Go through, and here you see, here's the peak, and you see also how narrow it is. It is really amazingly narrow. I never had that before. So we say send to SP. We go as usual here to about a 9 or 10. And now we start actually to stretch. We stretch and stretch. Now you slowly see something appearing, but what you also see is that the background gets bright. So let's now accept this. Now we have it here. You see also how small it still is. Usually you would have here such a bump, but it's really, really narrow. Send to SP. We will go to about a 6 as usual. We go on, and it gets brighter and brighter and brighter. I mean, if we go up here, it gets unusable. So we would have to go to about something like this. But I think you get the issue here. And how I actually solved it when I first time stretched it, I went to linear. Now actually I went here with a very small low clip, a little bit up like this. Stretched it like this. Now went back, generalize hyperbolic stretch, and now you see, now you have a decent graph. With that we can now kind of deal with. Send to SP, and now we can stretch it. So let's see now about this area here. Would be good if we could still pop this a little bit out. So at the end you get to something about like this. Let's compare this for a sec of what we had here in the screen transfer function. Much more intense colors, yes, but actually here it's worse. Here we had here the better contrast. So it is really a case where I struggled with GHS. So what else can we do in such a situation? It's actually the first time I had such a situation. Let's just minimize that for a second. And let me show you another way how to do it. And we actually start the same way as before with the screen transfer function and the histogram transformation. Move the triangle here from the screen transfer function to the histogram transformation and in here. And I know I said a lot of times that this is not the way to do it. But wait, it has a twist. Because now we're going into GHS. Because what I really dislike about this picture, it is overall too bright from my perspective. Not enough contrast. This is how the curve looks like. It's actually good. And what's very impressive if you go on a log view and you see that it really fills in the whole area, which is actually good. It is stretched to the max. You might even have here a little tiny bit clipping, but that's minimally. So what we want to do actually is move the whole thing a little bit to the darker side, but without actually having more clipping. And with that, I think we will get to a very good result. So what we have to do for that, first of all, definitely we have to protect the highlights. That's crucial. So we put a line here very much on the top. We say send to SP. Local intensity we keep at 0. And now we're increasing the stretch factor. And you see what happens. You see how the curve moves to the right and how the picture gets darker. And that's probably already good enough. If you look at it, I like this much better. And you see there's not more clipping here. And that's the good part. We moved the curve to a more darker part where it's more contrasty, but without clipping. So I'm going to execute that. We don't want more. That's actually was good enough. We close it down. But again, I want to show you this. This is a little bit an exception. And I wanted to show you this for cases because I read all over in Facebook. I have huge issues with GHS. And sometimes it's cases like this. And don't you hesitate to use this workaround if you're getting in such situation. But I would say with about 95% of the picture, you can really do it without any issues fully in GHS. So now we want to beautify this further and especially influence the colors. Even it looks already very nice, but let's see if we can get even more out of it. Some more oranges, some deeper blues. And I think always the first address is the narrowband normalization process of Bill Blanchard. And we'll see now what we can do with it. Definitely not that, but that's also HOO. We have to go to SHO because that's what we did. And I think you already see it right now that this looks already a million times better. The red is much more pronounced now than it was before. That looks lovely. Lightness is at the moment off. If you go to preserve, it's a subtle difference. And that's now really up to taste. I think I like it off even better. Now we can see SCNR. Do we want to reduce a little bit the green? I have a feeling no, it actually gets more blackish. Don't like it. Do we want to increase the HOO boost? That's actually nice. Gets bluer. Just have to be careful that we don't overdo it. And how about S2? Go. Might a little bit. Let's see again. This was it. This is now. And from my point of view, when it comes to the narrowband normalization, that's already all we have to do. Let's execute, and we're one step further to a beautiful picture. So next we go again in the toolbox, where my favorite script actually is Selective Color Correction. This is an extremely powerful script, and it actually makes everything else that you ever heard about color changes within these pictures practically redundant. So we actually choose first here the mask. For example, let's at the moment only work with the red. So we have here the red mask, and now we can actually go here to the red and say we want to have a little bit more. We increase it, we have to let it run, and you see how the red starts glowing. You can say we take the green a little bit back where the red is. Don't like that so much, and that's really the great part here. You can actually look at the effects in real time. We can also increase the luminance and the saturation. And here we can actually look now at the before and the after looks much better. If we like this change, we click on apply, and that's crucial here. Before you change a mask, you have to apply it. Then it says applying color change is finished. And now we can actually change the mask, and we can, for example, go to blue. Blue I definitely also want to increase, much better, perhaps even a little bit too much. But that actually looks good if we take the red a little bit back. Again, let's look at before and after, and the blue is much more pronounced. Very nice. Should we go up with the saturation? Why not? So then from this to this, beautiful, apply. How about yellow mask? Let's go up with the yellow. Yes, that gives now these very nice orangey colors. And I mean, this is now fully on individual taste. Nobody can tell you here what's good, what's not good. You decide what looks good in your picture. What we can also do now, we can not only do colors, we can also do filters about shadows, midtones, and highlights. Obviously the highlights, in this case, I don't have to bring it down, but I also don't want to bring it up. The darks are dark enough, but how about the midtones? Let's say we just want to, for the midtones, just give them a little bit more luminance. And yes, that looks nice. Afterwards, before, just extend that a little bit brighter here in the center. And with that, I can actually close the script, and here is our picture. That picture looks already amazing. So there is another script in the toolbox, which is called Improve Brilliance. And as always, we have to be a little bit careful with these tools that we don't overdo it. I rather tune this down a little bit to about 35 here. You can actually add a little bit of sharpening also, a little bit more luminance. Now we can say here, automatically update the preview. And when you're okay with it, you click the green hook. And here is the result. If you want to know what really happened, I did it before. That we will put now over this here. And now when we toggle, you see the difference it made. Much more intense colors now, more contrast, looks nicer. So really cool stuff. And in principle, that's it. Now, if there's still anything that would disturb you, you can always go into curves transformation, but when I look at that, I do not have to do that here anymore. This is just perfect now. Really nice. So now comes the moment of truth, where we have to combine this with the stars. Remember, here we have the stars. When I look now at the stars compared to this extremely colorful picture, I feel that they could be a little bit too white. So here I take now the curve transformation, and we go into saturation, and we just throw the saturation up. And yes, that looks already much better. And that's already everything I want to do here. Now these stars pop a lot more. So now obviously we would have pixel math, but hey, to use really all the cool new processes and scripts that exist, we actually take the one of atom block, which is called image blend. So view, we take here starless. View number 2, we take the stars. Blend mode is green, that is correctly. So now we already see how this will look like. We have a preview. And now comes the cool part, because if I feel now that these stars are too bright, I can simply play here with the opacity, put the opacity a little bit down until I feel it looks good. And that's about now the case. So this is really the cool part about this tool, that I can adjust the brightness of the stars. They still have the size, but they're not that bright anymore, that obnoxious. And when I'm okay with it, click OK. And here we go. And so that, ladies and gentlemen, is our final picture. And actually, I like it. It's always interesting. I processed this now before already. It looks different again, but really, really beautiful. And I think one of the reasons why it's so beautiful is obviously the amazing quality of the data. If you look at this here, it's just from a detail point of view, absolutely unbelievable. Okay, and that's it. I hope you got the same beautiful result out of it with whatever data you processed than I achieved. Please have a look at the description below. There's a lot of information in it and a lot of links. And as stated, all the rest and the PDF you find on my Patreon page. And with that, see you next time and clear skies.